Cloud.
Hello, everybody. My name is Derek Runberg. I'm Director of Product here at Makey Makey. Eli is with me here as well, and Eli's going to be kind of managing the comment side of things and stopping me if you have questions, all that fun stuff. If you have questions during the webinar, feel free to drop them in the comments, and we're going to try to periodically stop and answer some of those questions. And then we also have a Q&A session at the end where we can elaborate on some or follow up on some other questions as well. You should be here to learn about using CreateAI in your classroom with Microbit and Makey Makey. So with that being said, already did introductions. My name's Derek. I'll be your primary host, and Eli is with me as well.
Before we move
Uh,
any further, can someone in
yeah,
the chat confirm for me that audio and video is good for everyone else? I know we tested it beforehand, but okay, yep, I'm getting some yeses. All right. Thank you all. Carry on,
awesome.
Derek.
Cool. A real quick agenda for today. You're going to be with us for about an hour. Um, what we're gonna do is first we're gonna do a quick overview of an approach to machine learning and the format of AI with that, and then we're gonna walk through an approach that or a practice in the classroom. So we're gonna start with our Coda key with the Makey Makey and the microbit, and we're gonna progressively build up to a project that then implements CreateAI with that project as well. And then we're going to do a final Q&A and raffle. So we're going to be some slides and talking heads for a while, but we want to get hands-on and demo as soon as possible. So with that, I'm going to move to the next slide, but this is essentially what we're going to be doing with these as our goal. So our goal is to share what we have learned about AI and machine learning with you. Again, this is something new. AI and machine learning have been around for a while, but as a tool and something to use in the classroom, it's relatively new. And so what we want to do is share what we've learned, what we've played with, what we've experienced, in hopes that you pick it up and play around with it and to see if it's something that you can use in your classroom. And then what we want to do is provide a possible approach to AI and machine learning for you in your classroom. And we're going to model that example today. Now, this is not might not be the right model for you to move forward with. It might even seem a little clunky, but that's okay. But this is how, if you were to drop me or Eli into the classroom tomorrow and you said, hey, you got to teach machine learning, this is probably what I would end up teaching students in middle school. So that's kind of our approach for this webinar is we're going to go over kind of with that broad overarching idea of what is machine learning and AI, and then we're going to put rubber to the road on how to use that. Uh, One thing that we did want to say is that there's going to be a raffle at the end. So we're going to give away all of the materials that I use today to do the demo, which includes a Makey Makey or classic kit, a Coda key backpack, and two Microbit Go bundles so that one lucky winner will get it in the mail and they can follow along the video later and all the slides to just recreate exactly what we do here. But that will be at the end, so you got to be here to win it. So stick with us. So we want to give a quick overview of our approach to machine learning. Um, it might be a little different than the technically correct version of it, but we wanted to make it something that is student friendly, teacher friendly, and it doesn't take a doctoral thesis to understand. And so we wanted to look at this in a very specific way. So we want to really focus on what we call machine learning. And machine learning is a subset of AI. So when you hear AI, we were just at ISTE this summer, AI is everywhere. AI is like that big umbrella idea. It has a bunch of tools and software and a whole bunch of stuff underneath it. It encapsulates a bunch of ideas. Um, Machine learning is a part of it. It's a subset of it. And it's actually used in AI. Um, it's used in, but not at the scale of something like a large language model or a generative model or so things like ChatGPT. We're not going to be exploring that with hardware. We're going to focus on this machine learning idea. So again, it's something that's smaller part of AI. It's a very, very important part of understanding how AI works and how you can use it beyond something as just a chat tool or something like that. So what machine learning is, and this is again, according to our perspective in exploring this stuff with students, it's a subset of AI. We already talked about that. It is data focused. And what I mean by that is it's really good at crunching numbers and it focuses on collecting that data and then making sense of it as an algorithm. So it uses algorithms for us to make decisions. So, and you'll see that more when we get into the CreateAI part of this, but essentially collect a whole bunch of data, and then you say, hey, this is the data of me making a hand gesture of this way, of waving, and it will create an algorithm or a line that best fits for those data points. And it will say, yes, you're this, or no, you're not. And so it's a very binary decision tree. But it uses that advanced algorithm to do that. And machine learning is the process of teaching or training AI. So again, just like your students, computers to do be and or use AI, it has to be trained, and it's been trained by somebody. Some AI, you can just feed it a data source and it's constantly learning and updating on its own. And then others can be isolated, like what we're going to do today, isolated from its data source or its training model and rely just on what it's been fed. One of the reasons we like to explore machine learning is that it's what I call students' nuts and bolts scale. What I mean by that is that it's something that students can approach and use at a very student level scale with projects. It's not a tool that they just use to generate answers to homework as a consumer, but they can actually tinker with it, play with it, train their own machine learning models. So they're truly, truly learning how this all works, and then they're putting it to use. So again, and this is just kind of a follow-up to reiterate this, is why focus on machine learning? The best way to learn about AI is to be hands-on with the training of AI. So the best way to understand how a car works is to take it apart, put it back together again, change the oil, all that stuff. So it's the same thing, it's just now in a different format. And we learn that so that we can teach the AI model. The best way to learn about AI is to be hands-on with the training of AI as part of a system. So what we want to be doing is building a tool to serve our purpose. So we're going to use AI and machine learning to solve a specific problem or create a specific project or do something like that. It's not going to be the answer. It's going to be a part of the system that we're going to create. Eli, we have any questions so far? I'm going to stop there because I know I just did a lot of talking.
Nothing in the chat. If anyone has questions, please feel free to drop those in the chat for us, and we'll kind of ask those in between each section.
So if we're thinking about this as a system or as a physical project in terms of machine learning, it has its components. And one of the biggest components is the Makey Makey. I'm going to actually bring up my Makey Makey here. Oh, not that. I'll change that later. Change my camera so you're not looking at me. Oops, turn that off. Ugh. Eli, can you turn my video back on, please?
Let's find out if I can. Maybe. It is not giving me permission. Do you want me to make you the host?
Sure.
All right, you are host. See if you can get your camera back on.
There we go. Okay. So, uh, part number one is a Makey Makey. That's why we're teaching this, is because Makey Makey is the foundational part of this project. And all it does, Makey Makey, if you've never used it before, think of it as a keyboard and mouse that we've ripped all the keys off of it, and students can create their own keys and inputs for their computer. So they can make something like a banana piano, bongos with some wire. You can use buckets of water to build video game controllers, you name it, and students can build it with just building simple circuits. So that is the Makey Makey, and it, like I said, it's the foundational thing. So it acts like a keyboard and mouse, but you can now control your computer with bananas and so on. This thing is driving me bonkers. There. So the Makey Makey is your keyboard and mouse. The other part of this is the the microbit itself. And the microbit was invented and or created around 2009. Think of it as a tiny, tiny computer, very cheap computer, has the world's smallest, I would say, worst pixel display. It's 25 total LEDs as a pixel, two buttons, A and B button. And think of it, this is the little brain we're gonna put a machine learning model on. So microbit is right there, and it's got a whole bunch of sensors on it. The one that we're going to use today the most, actually, we're going to use two. We're going to use the microphone that's on it, as well as the accelerometer. And the accelerometer tracks motion as a sensor. We're also going to use it as our data source for our machine learning model. So like I said, we're going to use that sensor, and then we're going to program it to have it host that machine learning model and do something with it to control the Makey Makey. So from a machine learning and AI perspective, the microbit is going to be very, very important in this project, but it will end up controlling the Makey Makey, and the glue in this whole project is called the CreateAI backpack. And the backpack is a board that goes on the back of the Makey Makey. And then it allows us to plug the microbit, attach the microbit to it. And now the Makey Makey can control the microbit, and the microbit can control the Makey Makey. So what we've ended up doing is building this system that we can now play with and explore machine learning in a very fun and approachable way in terms of building game controllers and inputs for our computer on the mic with using the microbit and the Makey Makey together. And that's the main thing that we're going to focus on today. Eli, any other questions before we jump in?
So far, you were killing
Building
it.
up this project?
No one's got any yet.
Okay. So the first thing we're going to do is we're just going to actually do a quick example project using the CreateAI. We're going to have the CreateAI control one of our games. So every time that I clap, the construction Carl here is going to jump. Just as a quick preview, and I'm going to code this live. But as a quick preview, this demo is only going to take 5 blocks of code, which is incredibly small for what it actually does. And when you get the copy of these slides, know that where it says link is a hyperlink. It'll take you to this example code, and you can look at it on your own, play with it, fiddle with it, change it up as you see fit. So I am going to see if I hit escape here to get out of the, okay, good. I can do that. And I'm going to jump into make code. Eli, just double check. You're seeing the MakeCode window, correct?
Yep, you got
A
it.
little gun shy after the weird
I will
change
let you
in
know.
who's who here. So this is the, if you've never used MakeCode before, this is a free programming environment that Microsoft brought to the table to help with programming, the programming side of things for the microbit. Like I said, it's free. It's student safe. There's no sign-ins required or anything like that. And we're going to actually use it to program our microbit here. And I'm going to really quickly plug in my microbit. And let me try again to switch my camera here. That one. So you should be able to see the microbit. And what we're going to do is we're going to create, like I said, a controller that when I clap, it presses the W key. What we need to do is we need to add a quick extension, which allows us to use the CreateAI backpack. So I'm going to hit extension and I'm going to say Makey Makey. And that brings in some blocks. And again, if this is your first time seeing this, is okay. This is being recorded and there's plenty of tutorial content on MakeCode for you to get started with whenever you get a microbit in your hands. So with that, I'm going to just add this to start my Makey Makey or initialize the Makey Makey with get the two talking together. And then I'm going to use an event that I'm going to bring in. And I'm going to say, actually not on shake. Come on, Derek. I'm going to say on loud. Here we go. So when I make a loud noise, we want it to press and release the W key. And the one thing that I like to do, just so that I know that something uploads to the Makey Makey is that, or the microbit, is that it shows an icon, and I'm going to use a check mark this time. So again, here's those 5 blocks. So in other words, when the microbit starts, we initialize the Makey Makey, it's going to show a check mark. And then when it hears a loud voice, it's going to press and release the W key on the Makey Makey. And it's already connected, so I'm going to hit download. And you can see the code already loaded. There's a check mark here, so that means it already started. And what I'm going to do is I'm going to connect this. So I'm going to open up my runner game app first and plug in my Makey Makey. So you should be able to see that. And then when I hit play, if I clap, Carl jumps. So I know that my CreateAI is working. And again, it's reading the microphone saying when it's loud, press the W key, which is a key that's the pin on the back of the Makey Makey. And that's what the CreateAI backpack is connected to. So why did we just do this demo? Well, this is the hello world, or the very first piece of code that you explore with the CreateAI backpack and the Makey Makey. What we want to do now is elaborate on this project. What we're going to do, and one of the reasons that we like microbits so much as a partner and the CreateAI is that the microbit can talk to other microbits via wireless. And so once we get the handle of the CreateAI backpack and the microbit talking to one another, I'm actually going to unplug this so it stops hitting the W key. Once we get these two things talking to one another, we can now use other microbits in part of this system. And that's what we're going to do next, is that we're going to program so that we have a remote control now for our Makey Makey. And then the next step will be to add some CreateAI to that, a layer to that. So we're going to jump back to our make code here. And I'm going to swap out some microbits here. And I'm going to create a new make code program. And just like before, I'm going to go bring in the code key extension. So I'm going to say Makey Makey. And I'm going to initialize that Makey Makey as well. And since this is going to be, this will be the base station to another microbit. So this will be a receiver and this is a sender. So I have the sender already programmed so that when I press different buttons, it sends different things to the base station that will be connected to our Makey Makey via Coda key. But I need to get them talking to one another over radio. So I'm going to hit radio and I'm going to say
Can you zoom
radio.
in on your code blocks for us while you're doing this?
Yep.
Thank you.
Does that help? So we're
Yeah,
going
that's
to set the radio group to 1, which is basically like the radio channel between the two. And once that's complete, I'm going to give it an icon because I want to be able to see that both of these things have happened. Since this is the base station, we want to say when it receives something over the radio, do something with it. So we're going to say radio, on radio received. Do something. So this is an event block that will be triggered when it receives a number over the radio. And I'm going to use a basic if statement. So I'm going to say if else. And I know just because this is my demo here, I'm going to need 2 options. So I'm going to say on radio received, if that, and it's going to say if it's 0, if it's 1, and then I'm going to say 2. So, because it can get one of 3 numbers. It's going to be if something is a 0, a 1, or a 2. So with that, I'm going to make kind of our logic statements or comparison blocks. Bring this in, and I'm going to say if received number is equal to 0, do something. And then I'm actually going to duplicate this. And I'm going to say if it's 1, do something else. And then a third time if it's the number 2. So if it's a 0, I want it to press a key. And what I want it to do is I want it to press the W key. And I'm going to have it release the A key. Because I want it to pick between either the W or the A key or totally release both of them. So what we're doing is we're building a controller that uses the W and the A key together. If I get a 1, I'm going to press the A key and release the W key. And lastly, if I get a 2, I'm going to release all the keys. So in other words, let go of the keyboard. And that is the end of our code. So I'm going to actually hit download, put this on the microbit. So I've got the heart. We're going to test this. So I'm going to plug in my Makey Makey. And I'm going to open up an app that I pre-populated. So this is our interactive poster app. And what this is, the reason why I went with W and the A key is that when I press in this app, we can actually take images and map them to Makey Makey key presses. So if I press the W key, it shows no. If I press the A key, yes. If nothing's being pressed, it's me being like, what am I doing? What, yes or no? I don't know. So now what I've done, because I've pre-programmed this, and I'll show you the code. I have both of these talking via radio. If I press the B button, thumbs up. If I press the A button, thumbs down. If I press both, it actually releases the keys and it goes back to what would you like. So this is kind of a how are you feeling type thing. So if I'm feeling good, I can press the B button. If I'm feeling not so great, end of the day, B button. So that is the basic radio demo of just being able to create like little remote control feedback devices for our students using Makey Makey, then the Coda key with 2 microbits. Now, this is, again, like I said, a progression for your students. So this is not something we just jump into. There's some other projects and things like that. But I wanted to get into an application point for CreateAI. So we're now at a point where we can say, how do we make this sender? How do we make, oh, let's not that. There we go. How do we make this, the sender, the transmitter, smarter? So it's pressing A and B button, yes, but I want it to be a little bit more interactive. I want to, how do I integrate um, CreateAI and some machine learning into that? And that's where the CreateAI platform comes in. And I'm actually going to jump over to back into my slides here. In that, as you can see, we created both programs, both a sender and a receiver. We played around with the interactive poster in terms of how that works together. And now we're going to make it smarter. And one thing that I want to do is pause. And Eli, do we have any questions?
Yeah, we've got a couple, and I've answered most of them inside of the chat.
Okay.
One thing that I actually cannot remember from my own personal experience is you were doing all of this in MakeCode. How well does that work with the iPad? If you were to do Makey Makey plus Coda key plus microbit, is that going to function?
So iPad, you can program the microbit via Bluetooth and the iPad. I believe there's an iPad app for it specifically, but you can also do it, I believe, over web Bluetooth as well. Ideally, you'd plug it in, but again, just like Makey Makey, you need to have
A
a
dongle.
dongle and a USB cable for that. Ultimately, the best way to program microbit is with a Chromebook or a laptop because you want to be able to use those things. But it works similar to Scratch in terms of being able to drag and drop blocks. So from a touch screen perspective, it works just fine. CreateAI, on the other hand, hate to say it, but I have not tried it on an iPad before, so I can't give any feedback on that.
That was my next question is what about this next part that we're going to do?
Yeah. Yep. Cool. Any other questions before we jump in? Because we're going to spend most of our time in kind of implementing this next part of it.
I think we have answered everything in the chat so far.
Cool. So how do we make this sender or the transmitter part, the remote part, smarter? And the big part of that is why we're all here is with CreateAI. And you can see the diagram there that I actually snatched from their website is that we're going to go through this process for the rest of this workshop or webinar. We're going to go through the process of collecting data with the microbit and then training that model, training a machine learning model, and then improving it if we need to, and then implementing it in code to interact with our little remote control here. So what we're going to do, I'm actually going to jump to CreateAI. And the slides do take us through there we go. I'm gonna jump to CreateAI. I'm gonna get out of this so that you can see how we get there. If you've never used CreateAI before, there's a get started here, get started at the bottom. Either way, it takes you to the same spot. The great thing that I don't think most people realize this is that as you work in CreateAI, you can actually save a lot of your files. You can save your files, your the machine learning models, and a lot of that stuff. So be thinking about how to save during this because it's not always super apparent. But we're going to start with a new session. And we end up with a blank screen that looks like this. And at the bottom, it says, your microbit is not connected. So what I'm going to do, I'm going to disconnect the base station. And what I'm going to do here is I'm going to connect another microbit here that I have on a wrist strap. And I'm going to go through the whole process of how do we connect this thing and get it all going up and running here. So I'm going to shrink down that. I'm going to hit connect. And it walks me through the instructions. So I'm going to say next, connect the USB cable. I did that. And then download data collection program. So what CreateAI has is a specific program that's pre-programmed for you to download to your microbit. So we got to connect the microbit first. And I'm in Chrome. So I select the microbit that's already paired and I hit connect. And it downloads it for me. I don't have to drag anything or drop anything. It all does it for me. Do note that I am using, and CreateAI only works with microbit 2.0. So the one with the little notches along the bottom. I would say most people should be working in with 2.0s by this point. But if you have 1.0s, sorry, but this is something that you're going to have to use with a 2.0. I disconnect it and connect the battery pack and my pattern. So it gives me a pattern. Oh, shoot. Didn't mean to unplug it. Gives me a pattern to match and I hit yes. And now I have my Bluetooth turned on because what we're going to do is we're going to connect via Bluetooth to the microbit and it's going to live stream data and you're going to see it in a second. So I'm going to actually connect this to Bluetooth. And you'll see at the bottom now, this is the live data feed of the accelerometer on my microbit. So if I pick this up and shake it, you can see the line graphs. I'm actually going to turn the battery on and unplug this. And then I'm going to put it on my wrist. So one of the things that we've found with this is that you can do this without a wrist strap of any kind and just hold the microbit. But one of the things about machine learning is that because it's using data and it's making very binary decisions with that data, you have to keep your microbit in the same orientation you collect data in. In other words, we can't collect a bunch of data with the screen face up and then assume that it'll work with the screen face down because the data, if you see that, right, the blue line is at the top. If I flip that over, the shape of the graph is very different. And so we have to be very particular about how we orient our microbit when we're doing this. Now, a lot of you may have looked at me like, okay, he had to plug this thing in, Bluetooth, and so on and so forth. The first time through is a few steps. We'll just say it's a few steps. We totally get it. But once your students have done this once or twice, they're going to be off and running and they'll be totally good to go in terms of this. So that once they can collect data, they're going to be off and running and building amazing things. So next step, now that I have live data going and you can see I can move my hands around and it's got live data, I'm going to create a number of actions and I'm going to name them. I'm going to say one called yes, another one called no, and another one called nothing. So these actions, we're going to collect data of me doing an arm gesture that means that will be mapped to that action. If you were to talk in a more technical sense, these actions are classes of the model, but we call them actions here. So what we're going to do is we're going to record me doing these actions over and over and over again to, again, collect that data for us to train our machine learning model against. So there's a way to record these one at a time over and over again. If you click on the three dots, you can either record a number of samples or record for 10 seconds. Since I'm going to be making very simple gestures over and over again, I'm actually going to do it for 10 seconds because it's a very short gesture. But if you had something that was a little bit more elaborate, like a jumping jack or something like that, you might want to record 10 samples. So again, the more elaborate the sample or a little bit longer of time period, you record number of samples. If you have short, repetitive things, then record for time. So I'm going to hit record for 10 seconds. So this is for yes. So I'm going to do an up and down motion like I'm dribbling a basketball for yes. So I'm going to hit record. It's going to count down and I'm actually going to start right away. And I'm going to do one gesture consistently the first time. And it's recording 10 samples. And it gives me a picture of each of these samples. And you can see they're pretty consistent in terms of their shape. And I can scroll across here. They all look the same. And I'm going to record another 10 samples. And I'm going to do the same motion, but faster. So I'm going to say record 10 samples, 10 fast samples. I'm going to do the same thing and do something in between. And maybe even change it up mid-sample. What we want is variation of what we mean by yes. So the more variation of the same gesture, the better. What we don't want to do is mix in what we would consider no with yes, but we want to have a variation and different data points for what we want to call yes. And I'm going to do it one more time, and I'm actually going to do really small. And now I'm going to do the same thing for no. So I'm going to actually hit record for 10 seconds on no. And my no is going to be a horizontal back and forth. So you can see the difference in the graph shape. So 10 samples of kind of a standard one doing the same thing. And now I'm going to do 10 samples kind of small. And then I'm going to do 10 more samples of kind of variations of that in there. So something wild down to small. So I have 30. I'm going to do one more because I want 40 of each. And again, you can see that this would be super fun for students if they were, I mean, I'm doing a basic hand gesture because I'm sitting at a desk. But if they were doing jumping jacks or different dance moves, how you can characterize some of this stuff. So there are my my yes and my no data collections. Those are the two things that are going to be like positive things. Like that's what I want. Nothing is the action that most people forget about doing when you're building a machine learning model. And that is all of the white noise of me talking with my hands or me sitting still, all the stuff that is not either of those two. The more of this data, the more of the nothing data, that is the oddest way of saying it, the more of the nothing data I have, the easier the machine learning model will be able to pinpoint yes and no gestures. So we're going to record these things, and some of them will be me just sitting here with my hand still, so totally flatline for 10. And then what I'm going to do is kind of start to just move around a little bit. So I'm actually going to record 10 more and just kind of slowly move my hand and arm around. And the more data that I collect, the better off the model's going to be. So things like, again, talking with my hands and not worrying too much and being natural about motion is going to be the best thing for that nothing data or that white noise. So again, I'm going to change the orientation of my arms, my hands. I'm going to record 10 and I'm going to put it down to my side, rotate it, move it around. Again, just giving it white noise. I think we got enough. We got 40 of each. And what we're going to do, this is the great thing, is low stress because I can come back and add more. But we're going to train the model. And I'm going to hit start training. And this doesn't take that long. If you were doing a like professional level machine learning training, it would take hours. Some stuff takes days, depends on the computer you're using. But this does it in a matter of seconds. So you can see right now there's actually a live feed out of it. Knows that I'm doing nothing. And if I move my arm around, oh, I got a little bit of a no. So if I do horizontal, it has 100% certainty that this is a no gesture. If I go back to sitting, it's nothing. And then if I bounce my hand like bouncing a basketball, I get a yes gesture. So this is actually a pretty clean model. I can move it around. Awesome. If for some reason we weren't happy with this, we can go back and edit the data and add more samples to our yeses, our nos, and our nothing. But I'm pretty happy with it. So I'm just going to hit test. It'll take me back here. Notice this over here. This is make code blocks that we can see. So we have, hey, by the way, yeah, like this is a yes. And that would trigger this block of on ML yes start. So this is an event block in make code. It's just showing me the example of when this is triggered, it's going to do whatever I put inside of this block. For us to use this in code, we're going to edit down here, edit in make code. And it'll bring up its own make code window. So one thing that is somewhat confusing at times is that when students go to implement the machine learning part of make code here, they're like, hey, I did this thing and I want to implement it in my make code project. The CreateAI version of make code is slightly different than the make code that we were using before with our clapping. And so these files don't save to their normal make code account. So that's one thing that it's different environments. So that is a little bit of a tough part of this is that it looks the same, but it is different. Little bit of a note there. So we have our 3 machine learning blocks on yes, on no, and nothing. And we're going to actually take these icons and we're going to get rid of them. We don't need the pictures to show up. This is going to be our remote. So instead of the A button, B button, this is going to be A button, B button, and nothing. So we're going to replace them with our, instead of button press events, our machine learning events. So I need to bring in a block that it was in the previous code that I don't have, which is the on start. And I'm going to add the radio set group because I want to make sure that I'm connecting to the radio. And then, like I said before, I always add an icon at the end of on start. So on start, we set the radio group and show a heart. Awesome. Now, when I do yes, I want to send a number, not that, sorry. I want to send a number 0 to yes. For no, I'm going to send a number 1. And on nothing, I'm going to send, oddly, a 2. So in other words, if we pulled up our code from our previous MakeCode project, so if actually, I'm going to do that. My previous sender. So A button was 0, B button was 1, and A plus B or nothing was 2. If I go back, I can compare that 0, 1, and 2. It's essentially the same program, but now instead of a button press event, it is a machine learning event. So I'm actually going to load that to the microbit I'm wearing right now. So I'm actually going to plug this in while still wearing it. And I'm going to hit download down here. Download. And this will be a little bit of a different download than previously MakeCode. It'll double check with me. Hey, download your machine learning project. Your program includes machine learning. It just gives you a warning, yes or next. This is the same microbit we used for training. So we're going to say same microbit. Next, and then it asked me to pair it again. So I'm going to go pair it like before. And that is on this microbit on my wrist. So now it should, I'm going to plug in the base station here, and I'm going to change my camera so that when I go back to the interactive poster, if I do a yes, no, oh, here, I got to click on this. There we go. No, yes, okay, nothing, yes. Oh, I had it backwards. Shoot. So I had the numbers backwards, so I can actually change these around. But the idea of this 1 should be here and the 0 should be there. So let's do this. 1, 0. And I can actually re-download it. Never works on demo day, but that's okay. I'm going to hit download. Okay, and interactive poster. So now if I click on this, no. Yes. No. Yes. At rest. So again, now I've added machine learning to this project and just added this in layers. And one of the things, I'm going to unplug this before I do something that I'm going to regret in terms of controls. So we've gone through this process now of training the model, implementing it in code. We just tested it. And when we look at the two pieces of code, there's A button, B button, A and B button, and then it's almost the same thing. We've just replaced those event blocks, those pink event blocks with blue machine learning event blocks from a code perspective. So depth of project doesn't always equal more code. So you just because something is machine learning doesn't mean it's a crazy crazy mess of code all the time. And so that's one thing that I want to make very clear is that you can do machine learning projects with your students, and the process is a little bit longer in terms of training, but it's something that mirrors and emulates the real world in a lot of ways, from engineers that are using machine learning models to then produce something in a very rich way. So we saw that we progressed from just a hello world to a remote control to then a remote control with um, gesture recognition, which is pretty stinking cool. With that, I want to open it up questions, and then Eli, also just if you have any comments as well, and thoughts to kind of close things out before we raffle off some hardware.
Yeah. So far, I think you've done a pretty good job because everyone is uh, following along pretty clearly. What is this one here? I'm curious to see the AI screen when you try. Oh, okay. We were talking about how you had numbered things wrong. So you could just retrain the model on the new one,
Yeah.
which would also work, but would take more time.
Yeah.
So just so I'm clear on this. What you did was, we built you have the Makey Makey app, and it's controlled by
Mhm.
Makey Makey buttons. You plugged the code key and the microbit into that, and effectively the code key and the microbit are just pressing the buttons that control the app. And the AI part of this that you've built is interpreting the motion on the microbit that is on your wrist that then sends the signal to press the button.
Yeah. So all of the machine learning, the AI lives on this microbit. And by the way, this blue thing is just a battery pack on a wrist strap. So this is actually a pretty cool product by our friends at Forward, rechargeable battery pack with a wrist strap. So just did want to give them a shout out because it's been a pretty cool accessory. But the all of the machine learning stuff lives on this microbit. So I left the code on the base station on this microbit alone. So as long as I know what I'm sending it, and that's where when I just flip those numbers really quickly, I got in my head mixed up about what numbers I'm sending. And so I can really quickly just modify the code on one of these microbits to use CreateAI and not have to rebuild the entire system.
And so because someone was asking about this specifically, talk about like at each stage of this, obviously starting with just you have a Makey Makey and the app, all the way through to the CreateAI. What are sort of the age ranges or grade levels that you see if you were to move someone through this?
Mhm.
What's the earliest they could start at with a part of this project, and what part is the most advanced, and where do you need to be up for that?
Yeah. Makey Makey, third grade, second grade, even depending on the project and how elaborate you want to get. But Makey Makey itself, we start out at third grade. My experience at middle school, you could do this whole thing with middle schoolers. So sixth or eighth through eighth grade is just like a nailed it age. You could even do a lot of the machine learning stuff at high school as well. And that's one of the areas that we're super excited about is like how do you scale this up into some pretty elaborate machine learning projects for high school students. We showed you three actions if you include nothing, but that list of actions can get very, very long. We were at Computer Science CSTA National Conference earlier this summer, and I had six different gestures running off of it at the same time with no problem. So you can do a number of things. Right now, it only runs and uses the accelerometer on the microbit. Um, we're hoping and keeping an eye on if more sensors kind of get brought online in the system, because I think that that would be an elaborate or an amazing way to an amazingly rich opportunity for some machine learning in the classroom beyond just motion and movement, because you have microphone, you have a temperature sensor, you have a compass, a whole bunch of stuff that's on the microbit that, to be honest, we really want to play with. Yeah. So I would say,
Uh,
third grade, and then be this machine learning stuff is middle school. Microbit and the CodaKey backpack, you could probably do at fifth grade. I'm
I
thinking
have
that.
personally done it a little bit at fifth
Yeah.
grade, very, very briefly, but we saw some success there. There's a question here that this person is just like after your heart. They said, "Have you tried creating a game where multiple students are in one radio group and each of them controls a different part of the, the
So
button
those
press or the
that's
movement?"
we call them collaborative controllers. So yes, the answer is yes. Is that for example, we've done it. We have a Space Rocks app, and that one controls the thrusters, one controls steering, and the other controls the laser uh, gun. So you can see that by me doing one gesture is doing something in terms of turning left or right, and then the other one is shooting the laser with a different gesture. And so it from a distance, it looks like we're all doing a weird interpretive dance, but we're actually playing a video game. Um, but yeah, that's one thing that would be a great exploration using CodaKey and Makey Makey. I have also started to play around with the idea of, if I had two wrist straps, combination of two AI models, different models. So AI gesture recognition for my left arm and and combining those two at the base station. So if this is doing this gesture and this one's doing this gesture, what does that mean? So you can have multiple AI microbits or machine learning microbits feeding into that central base station as well.
You and I have talked a little bit about like the dream of basically doing Wii motion controls for Minecraft with it, where you actually have to
Yep.
mine. So yeah, we'll figure it out. Uh, okay, going through the question. Yep, playing the air drums would be awesome. Uh, yeah. Someone is talking about doing the poster and how adding this backpack on and being able to. That's one of the things I think is really cool is you have like the easiest level of this, and then you can enhance it with more complexity as you go by sort of scaffolding these different parts of the project that you've layered together.
Yeah. Yeah, and this can go, like I said, go in a number of different directions. The one thing that I have found, and this isn't necessarily a critique on CreateAI, but because of the amount of horsepower that machine learning models need, that the responsiveness for the CreateAI events are slightly slow in terms of like our human nature of like we want something immediate, especially like a video game controller, right? We want as little lag as possible. And so playing a game, like I wouldn't play something like our bouncy face version of Brick Breaker or Pong with this, because you want to be really responsive and not. So if you're selecting something like the poster app, that's amazing because you're kind of pressing and holding a key. If you're looking at like type fast, there's other ways of doing it.
Yeah, something like a Harry Potter wand type gesture where it's just passively waiting and there's not a reaction timer happening, as
Mhm.
opposed to steering or something like that.
Yeah.
Okay, cool. I think we might have anyone. Last call for questions in the chat. Think we are good, which means
Drum roll.
the moment we've all been waiting for. Hold on, let
So wait,
me.
wait, before you do this, because I know you're gonna say somebody's name, and then everybody else is gonna be bummed. So here's the thing. Right now we're in the middle of our. I'm gonna give everybody a heads up. right now we're in the middle of our back to school sale. And so if you're one of those people that are bummed you didn't win the raffle, that's always me, by the way. I've never won a raffle. We have a 10% off store-wide sale coming up. So, and that applies to CodaKey. But then we're also going to be sending out to everybody that's on the mailing list that joined and signed up for this. You'll get a discount code for purchasing a CodaKey as well. So if you want to try this out and you have a microbit and you want to play around with CodaKey, we're throwing discounts at you right away so that you can get one yourself as well. But we have one special person. Who is it, Eli?
Yeah, I have done our random drawing generator thing. Let me make sure that they are still here. They are. Carrie Brillhart.
What was that?
Carrie Brillhart.
Nice.
I see that you're still in. I don't know if you pop into the chat if you can hear us.
So we need to make sure, don't send it over the chat, obviously, but we'll maybe pull you into a separate room or something like that and get a shipping address from you here, or maybe we'll email you. I don't know. We'll figure it out. But we'll get your shipping address and we'll get a Makey Makey kit, a CodaKey backpack, and 2 Go bundles to you. And by the way, the Go bundles will not be in an individual box because they're coming out of a Code Club pack that I have sitting here on the desk. So they'll be individually kind of dispersed. But they'll be perfectly new. They're sitting right here. I'm looking at them. So we'll get those in the mail. Again, if you have any questions about this, please email us at support@joylabs.com. Both Eli and I look at that inbox multiple times a day, so you probably will, actually, I know you'll get an answer from one of the two of us. Again, that's support@joylabs.com. I think Eli's going to drop that into the chat so that you have access to that if you've got questions. And that's what we're here for. We want you to explore using this stuff in your classroom. We're constantly playing around with it and coming up with new applications and new ways to teach it. And this is just one way that where we're at now. So with that, I just want to say thank you to everybody. We're 2 minutes over. Eli, you want to stop the recording and
Yep, I'll do that
say
now.
good evening to everybody. Well, good evening, good morning, and good night. Is that the saying? What is the?
Good afternoon. I'm thinking Truman Show, right? Good afternoon, good
Yeah.
evening. Yeah, I make you host. You have to stop the recording.
Oh, okay. I will stop the recording. I will need to find the recording. Pause. Stop recording. There it is.